Good afternoon. This is Mr. Morales, and this is the second half of our video for solving systems. And this time we're going to be working on solving by substitution. Now, I do have some notes on the top of this assignment that explain the process, but I'm going to go ahead and just get right into it. So for number 7 on the back, our first example on this side, it says solve each system of equations below by substitution. Now, I kept making mistakes when I was trying to make this video because I keep forgetting to substitute. Since I know other ways to do this, I kept reverting to those ways, but I'm going to stick strictly to substitution. They want us to substitute and identify the solution. So substitution means you're going to be plugging in one equation into another whenever possible. So for example, number 7, we have y equals negative 7x minus 1 and y equals x minus 9. So we have two things that equal the same exact thing. In this case, both equations equal y. So since the first equation equals y, and the second equation equals y, that means the first equation, 7x minus 1, has to equal the second equation, x minus 9. So what I did is I substituted this equation down here for y right here, because it tells me that's what y is equal to. When I do this, I'm going to go ahead now and combine my like terms. I'm going to go ahead and bring my x's from the left side to the right side. I'll do that by first adding 7 x's to both sides. When I do that, these cancel out. I get a negative 1 on the left that remains. I get x plus 7x, which is 8x, and then this minus 9 falls down. Now I need to get my x alone, isolated. To do that, I'm going to go ahead and add 9 to both sides to combine my like terms some more. Negative 1 plus 9 is a positive 8. This 8x falls down. And then now all I need to do to get x by itself is to go ahead and divide. I'm going to divide 8x and the 8, both of those things, by 8. Now 8 divided by 8 is a positive 1. 8 divided by 8 is a positive 1x over here. So x equals 1. That's the first part of my answer. But I still need the second part, which is going to be the y value. I have two equations that both equal y. I can pick either one I want. I'll take the second equation because it has less steps. Y equals x minus 9. So now I will substitute the one that I got down here for x. So I get y equals 1 minus 9. And when I do this math, 1 minus 9 is negative 8. So my solution is x is 1, y is negative 8. And I can always verify that through graphing. Moving on. Now I have question number 8. Y equals negative 5x plus 30 and 7x plus 3y equals 42. Since we're dealing with substitution, I know that y equals this piece right here. So I'm going to plug in this whole equation, or substitute it in other words, for the y right there. So then what I get is 7x plus 3, and instead of saying times y, it's going to be times negative 5x plus 30 equals 42. I'll use distributive property. 3 times negative 5x is negative 15x. 3 times positive 30 is positive 90 equals 42. If I combine my like terms, 7x minus 15x's is negative 8x's plus 90 equals 42. Solve this like a two-step equation. I'll subtract 90 from both sides. And I get, on the left side, negative 8x falls down. These 90s cancel out. 42 minus 90, it's going to give me negative 48. I'll divide both sides now by negative 8 to get the x isolated. And I get positive 6 because the negative divided by negative is a positive. There's my x value, but I still need to get my y value. So I have a y equals equation right here. To get my y value, I just multiply negative 5 times whatever my x value is and add 30. So I will substitute in my x value, which is positive 6, and add 30. Negative 5 times a positive 6 is a negative 30. Negative 30 plus a positive 30 gives me a result of 0. So my solution is when x is 6, my y is 0. That is their point of intersection, where the two lines will meet. Going on now, clean up my screen a little bit. I got some mess here. Whoops. Didn't mean to make you guys dizzy there. There we go. So now we're going to go on to number 9. Let me change this color out right quick. Something a little more interesting. All right. For number 9, we have 6x minus 5y equals negative 28, and 7x plus y equals 22. I need to get at least one of these equations into one variable. So I'll take the bottom equation, and what I'm going to do is I'm going to get the y by itself, and I'll do that by subtracting 7x from both sides. When I do that, this cancels out, and I have y equals that minus 7x with a positive 22. What I did was that minus 7x that I had right here, I just brought that down and attached the positive 22 at the end of it to make my life a lot easier. So now I have a y equation, y equals negative 7x plus 22. I will then substitute this equation right here for y into the first equation. So when I do that, I get 6x minus 5 times negative 7x plus 22 equals negative 28. With some distributive property, negative 5 times negative 7x is a positive 35x. Negative 5 times positive 22 gives you negative 110 equals negative 28. I'll combine my like terms. 6x plus 35x is 41x minus 110 equals negative 28. I will then add 110 to both sides to get rid of it and get the x by itself. When I do that, the 41x falls down. These cancel out. Negative 28 plus 110 gives me 82. I divide by 41. And then I get x equals 2. There's my first answer. Now I need to get a y value. Well, I already have an equation or I'll use this second equation here because it has a y that's all by itself, so it requires less work. 7x plus whatever my y value is that I substitute will equal 22. So 7x, my bad, I want to get the x value and I kept talking about y. So what I'm going to do, let me go back here really quick, is I'm going to substitute my x value in. There we go, that makes more sense because I just found an x value. So 7 times 2 plus y equals 22. There we go now. 7 times 2 is 14 plus the y that I'm looking for equals 22. To get that y value, I'll subtract 14 from both sides. And the y falls down. This cancels out. I get y equals 22 minus 14, which is going to be 8. So my solution is when x is 2, y is 8, and that is their point of intersection. Moving on now to number 10. Number 10 says x minus 7y equals 53, and negative 4x minus 5y equals 19. What I'm going to do is I'm going to go ahead and take my first equation, the x minus 7y equals 53, and I'm going to get x by itself. I can do that very easily just by adding 7y to both sides. So the x falls down, these 7y's cancel out, just make that an x, equals. When you have numbers and letters, stuff with letters or variables comes first, and then the constants, the numbers, will come at the end. So I have x equals 7y plus 53. Now that I have a single variable, I'm going to plug this equation in for x right there. So when I do that, I now get, and it's going to be quite a bit of work, it's going to be negative 4. Instead of saying x, I'm going to use this equation right here, 7y plus 53 minus 5y equals 19. Now I'm going to go ahead and apply distributive property. Negative 4 times 7y is negative 28y. Negative 4 times positive 53 is negative 212. Then I have this minus 5y on the outside equals 19. I'm going to combine my like terms. I have negative 28y's minus 5 more y's. So it becomes more negative and it gives me negative 33y's. Minus 212 equals 19. I'll now add the 212 to both sides to get the y's by itself. When I do that, This negative 33y falls down. This cancels out. 19 plus 212 gives me 231. And then I'll do some quick division with my calculator. When I divide both sides by negative 33, I get y is equal to negative 7. Cool. I got a y value, but I still need an x value. So I'll go ahead and just use my first equation up here because it has an x that's all by itself, and plug in the y value that I got down here into it. So I have x minus 7 times my y value, which is negative 7, should equal 53. Negative 7 times negative 7 gives me a 49. So I get x plus 49 equals 53. I'm running out of room, so I'm just going to count manually. To go from 49 to 53, you have to add 9, 10, 11, 12, 13, 4 more. So x equals 4. So our solution for this one is when x is 4, y is negative 7, and that is their point of intersection. And the final example I'm going to do, because I did leave out number 12 for this week, is number 11. Number 11 is pretty straightforward. So we get 2y equals 6x plus 10. This one has a little trick we can use. When you have an equation where all your coefficients, that's all the numbers, are divisible by a common number, you can actually simplify them to make them easier and smaller to use. So I have 2, 6, and 10. All those can be divided by 2. You can only use this trick if every number is divisible. So 2 divided by 2 gives me y, 6x divided by 2 gives me 3x, and positive 10 divided by 2 gives me a positive 5. So now I have a nice equation with one variable, y equals 3x plus 5. I am going to plug this equation in to, I guess I'll do it down here on the bottom one for y. So I get 3x minus my equation, 3x plus 5, should equal 5. 3x minus 3x cancels out. So I have no x's left. All I'm left with is a negative 1 times 5, which is negative 5. Negative 5 does not equal positive 5. That means we have no solution, because the answer on the left does not equal the answer on the right. All right, so those are your 5 examples. I did leave out number 12 on purpose. We said we'd work on that later, so we will do it later. But here's your video, and I hope this clarifies things a little better for you. If not, feel free to come in the morning and ask questions. Have a great day, guys.